I'm very excited about this particular session because we've got an excellent speaker helping me out today in the form of Polong Lin. So Polong, do you want to give a quick intro to yourself?
Sure. Hi, everyone. I'm a data scientist and developer advocate. My focus is on helping customers, helping data scientists make the most of data science on Google Cloud. So happy to be here and share what I can.
And then myself, so for those that have joined one of the previous sessions, apologies again for yet another introduction to myself, but I am Ollie, the CTO for our Google Cloud Platform team here at CTS, and I look after a team of architects who help bridge the gap between business conversations and technology. So helping organizations design solutions and then working with our engineers to make sure that we build what we said we would. So today we are going to talk about Vertex AI, and we thought we kind of put Vertex AI within the context of an actual use case. So something very typical, especially if you're a user of Google Analytics, Google Analytics being used quite widely by various websites or mobile developers to kind of understand how users are interacting with their application or with their websites. And you can do a lot of cool things with that data. So one of them being churn prediction. So is a customer, for example, likely to either cancel their subscription or likely to be lost as a revenue generating customer? We can take an example and put it into context as, for example, mobile games. So let's imagine we are a mobile game organization. Polong and I have just launched a brand new game. We're very excited. We're in the news everywhere. We've got a whole bunch of users, million users on day one. Then 24 hours later, we noticed that our user base has gone down by 75%. And this is what we call user churn. And as part of that act, we're trying to understand why that is and can we try and predict whether this is likely to continue or not based on historical data that we have from maybe other games that we've recently launched, or even from this game itself over a longer period of time. The way that you normally would do this is through the use of machine learning. So machine learning being used in a wide variety of different contexts effectively means you're using historical data to be able to then infer or predict on future data. In the case of a propensity to churn model, you'll end up with a score between 0 and 100. That's typically how it works in terms of percentages. Obviously, when you get a 0, that means you've got a very reliable customer. They're probably going to come back. If you get in the 50 range, they're on the fence and you probably want to incentivize them, maybe target them with a particular offer or a particular, message to try and keep them on your platform. Or if the model returns 100%, then obviously you're in trouble and that user is very likely to, stop being a revenue generating customer. Now, why would you want to use machine learning in the use case of propensity to churn? Well, I kind of already hinted to it, especially in the use case of like those customers that are on the fence. You can use those predictions to actually activate through various means to make sure that you try and target those users, try and, maybe send them an offer, send them a newsletter, send them a customized message to kind of make them feel as a valued customer and keep them on your platform, or in our case, our mobile game. The way that you would do this is you would kind of, build your machine learning model, and Polong will shortly explain how to do that. You then take those predictions, put them in something like Bigquery, and then push those into your marketing stack, which could either be a combination of Google Analytics if you're using that, or Firebase, or any other third-party marketing tools. But the thing is, developing machine learning is quite easy. Everyone says, oh, I can easily create an ML model, write a couple of lines of code, I've got something working. But the reality is, I think it's a stats which says that up to 20% or 30% of organizations never go beyond the stage of a POC. They build this awesome machine learning model as a POC. Someone, has done it on a development environment, but they don't productionize it. And the reason for that is because running machine learning in production requires a lot of different moving parts. It's not just writing your machine learning code. You have things like, data verification. Is the data, not changing over time? Is there any kind of feature extraction or any additional processing we need to do on the data to make sure we're not adding bias, for example? How are we actually going to train the machine learning model at scale? It might work fine on a local laptop, but how does it work over terabytes or petabytes of data? How are we going to evaluate how the model is performing over time? So there's a whole range of different things that need to happen. And especially, you know, as kind of mentioned, there's a lot of difficulties that make it hard to run machine learning in production. And here's kind of an incomplete list of some of the most important ones. So as I mentioned, reproducibility, tracking, monitoring, security, scaling, a whole lot of things to think about. So obviously the question is, what can Google Cloud do to help us in this particular scenario? And for that, I'm going to stop sharing my screen and hand over to Polong.
Perfect. Thanks for setting the stage, Ollie. So in this next series of slides, I'll kind of cover what you can do with Google Cloud when it comes to building out your entire data science and ML and MLOps pipelines from end to end. So kind of to start, you have to find a place for your data to live. And when it comes to data warehousing and for structured data, you're kind of looking at Google BigQuery. And this is where you'll see a lot of magic happen when it comes to data analysis at scale. So not only do you store your structured data, you can also run fairly complex SQL queries. And here this is an animation showing a fairly complex query that's running this analysis over 500 gigabytes of data in 5.5 seconds. And it's blazingly fast, considering the alternatives of doing this just with Python or with R or something else. This is extremely fast, and it's auto scaling as well. So as a user, you're not having to worry about the infrastructure. You're not worrying about what do you need in order to process 500 gigabytes of data. This is all handled for you in BigQuery directly. So that is kind of your analytics picture. But what about other things? So what about machine learning? So first of all, you can do some machine learning in BigQuery directly using BigQuery ML. So you can create your models. You can even deploy your models in BigQuery ML. And then from there, how would you take your ML to the next level? Well, there's ML for everyone on Google Cloud. So whether you want to use pre-existing pre-trained APIs for machine learning, so this could be anything from video intelligence to computer vision to text to NLP. You can use these pre-trained machine learning APIs. There's also some AI solutions built in as well. If you want to, for example, do something around document analysis using document AI. If you're not, a company or a team that has a lot of deep data science expertise, you could rely on something like AutoML to be able to derive your models for you without having to worry about the nature of choosing between different models and tuning your models. And then finally, you can, of course, create your own models depending on your skills and your needs, and go end to end, as Ollie mentioned, from building your model to monitoring your model and seeing how it works and lives in production. So where does this all kind of sit in Google Cloud? Well, Vertex AI is sort of the umbrella platform. It's the managed ML platform that is fully comprehensive and is meant to make this entire end-to-end experience really easy for data scientists and data science teams. Now, what does that kind of look like, and how does that sort of work? Well, the first thing is, for many data scientists, notebooks are kind of the go-to way to experiment, prototype, and even to deploy their machine learning frameworks, their models into production as well. So notebooks on Vertex AI, we call this Vertex AI Workbench, but this allows you to use your familiar Jupyter Notebook environment, be able to spin up notebooks of almost any size. It's lots of range of capabilities here. So whether you want certain number of CPUs, certain number of GPUs, you can customize it by a click of a button, really. There's integration with Git and full access control embedded as well. So I'll give a quick demo of this after this session. And so notebooks are surfaced on Vertex AI through the Workbench. And I'll show you kind of what this looks like. But essentially, this is the Jupyter Lab environment, but it also has connectors to BigQuery and to Google Cloud Storage. So you have this one sort of window where you can work with your modeling, work with your code in Python, in Spark, in R, and other frameworks. And you can also see your data directly in your Jupyter Lab environment. Make it really easy as a data scientist. Do not have to navigate between various windows or various tabs. You can see your BigQuery data and your GCS data, your cloud storage data, directly in the context of Workbench. Now, also within Workbench, you can do everything else that I'm about to show you as well. So you can train AutoML models if you'd like to. You can also use the point-and-click interface if you want to instead. If you don't want to go through the process of writing code for AutoML, you can point and click to train your models. There's also custom training. So this is where, of course, you'll probably need to be writing some code, but you can deploy your models as containers. And so this is where you can have your models trained in the cloud for you with some automated hyperparameter tuning built in if you'd like. Once you have your model trained, the next step is really to deploy and have it ready for live inference or batch inference, whichever may be the case. So we call this endpoints. So you can deploy your models as endpoints and then set where you want to deploy your models to and where it wants to be doing this real-time or batch inference as well. When your model is out there live and running, there's two things you really want to consider. How do you deploy and train and deploy in a very reproducible way, such that anytime you have a new model that comes, you can easily redo your train and deploy process. And then the second thing is monitoring of your model. So the first part is pipelines. So this Vertex pipelines allows you to kind of find a reproducible way to train, deploy your models end to end. So you can trigger your pipelines in a variety of different ways, but this allows you to kind of deconstruct how you go about deploying your models and making them go live through a series of what we call kind of components in a pipeline. So this is one way to do so. And it's managed and it's serverless, making it really easy for you to deploy these pipelines. Now, the second part was model monitoring. So this is where once you have your model live and up and running, you want to make sure that the model is not going stale. It's not drifting or skewing. Those are the terms. But essentially, the data that was used to train the model may be different in production. Some things may have changed. The distribution may have changed, or your audience may have changed, or something may have changed. So your model may no longer be predicting in the same level of accuracy or performance as you kind of hope it would when you did the training. Maybe it was a week ago, 2 weeks ago, months ago. Maybe it's kind of gotten stale over time. But how do you keep track of that? And when can you get alerted that these things and these changes have happened? Well, you can use model monitoring. So you can essentially set that up as soon as you deploy your model to an endpoint. You can check model monitoring, and it'll keep track of your model for you and keep track of the data distributions. So if anything changes, you'll be alerted by email. And this can all be set up directly from Vertex AI or through a notebook or through code. So whichever way you'd like. I want to go through a quick demo of what that kind of looks like end to end. So give you a quick demonstration here. So first here I have, hopefully everyone can see this. This is Bigquery. So in order to navigate to this screen, I've gone to this hamburger menu on the top left, and I've kind of scrolled down to Bigquery. I've pinned it up here, but you can kind of click on Bigquery if you find it and navigate it down below. But Bigquery is the data warehouse on Google Cloud. And this is where I have lots of different tables in Bigquery. So for example, I have my training data here under demo churn prediction. So if I click here, I've opened this up and I can see under preview and under schema, this is my table. Here I may have some, this is simulated data, but this is some data on my particular app that Ollie and I may have created. And we're looking at trying to predict churn for this particular data set. Now, how would I go about kind of working with this? Well, I could run queries directly in Bigquery if I wanted to. So I could write my SQL queries directly here if I wanted to. But for many data scientists, they prefer working in notebooks. So how do we combine Bigquery data with notebooks? Well, we can actually use Workbench directly for this. So here I'm opening what Workbench is like. And so you can see here, this is a fairly standard JupyterLab sort of looking environment. Now I have a notebook open in this main area where I have some simple Python code. And I also have here an interactive Bigquery editor. So I can essentially run my code directly in this interactive editor, and I can get the results live. And if I would prefer more of a Pythonic feel to this code, for example, I could click on query and load as data frame. So there's this button here, query and load as data frame. And if I click that, it creates a new cell down below where it says from google.cloud.bigquery. Essentially, this is the Python client library. So now this is the Pythonic way of doing it up ahead. And the reason why you might want to consider doing this is, well, you may want to experiment, try to iterate a couple times, find the right schema or find the right data that you're trying to look for and pre-process. And then afterwards, once you're you've settled on something that you want to use more permanently, then you can convert that into this sort of framework in which you're using the Python client library to call your data in Bigquery. And then you might be wondering, well, how do I kind of keep track of my tables in Bigquery? So you could take a look at the Bigquery button on the left-hand side. So you can see my mouse here on the left-hand side. It's clicking on this Bigquery button here. And you'll see in my project, which is called Vertex Workshops, you'll see lots of my data sets in my tables here. So I could actually double-click on training data here. And it will actually open this little tab here where I can preview my training data directly within the context of the notebook, which makes it a lot easier to keep track of where my data is, what does it look like, and also work directly within that notebook environment as well. So this is a quick view of Workbench. Some other capabilities of this include, for example, if you want to look at your data stored in Google Cloud Storage, these are my various buckets that belong in my GCP project that I can inspect. I can look at the files within that. Another thing that you can do as well is suppose you do have some sort of notebook. Well, in this case, I'm really kind of just printing hello world on the right-hand side here, and I'm doing some select statements. So nothing particularly outstanding. But if I did want to deploy a notebook or have it run on a recurring basis, maybe it's training a new model on fresh data every time it runs, I could schedule this notebook as well. So in order to schedule that, I could click on the executor or the executor button, and it can run this notebook at a particular time or on a recurring schedule. So I can give this execution a name, choose a bucket where I want to store the results, choose a machine type, accelerator type if I want to add in a GPU, the kind of environment, and whether I want it to be one time or on a scheduled-based recurring execution. And I can click submit, and it will run the notebook on this particular schedule. So on the left-hand side here, you'll also see the same logo, that little executor little button there. And you can see a list of all the executions that you've done in the past, and also any ones that you may have scheduled in the future as well. So this gives you an ability to check and track your scheduled notebook executions. Now, if you do have a pipeline, as I mentioned, a pipeline as a way to train and deploy your models set up, which you can also deploy from a notebook, you can keep track of your pipelines directly in the Vertex AI UI as well. And so to get to here, I've clicked on the hamburger menu. I've gone to Vertex AI, and I'm here now at pipelines. So I've clicked on a single pipeline within my list of pipelines. So you can see here, in this particular pipeline, it might be a little bit hard to see, but you see in this particular pipeline, it's ingesting some features, it's doing some custom training, and then it's doing some evaluation before deploying and depending on a condition. So lots of different capabilities of Vertex AI, from using notebooks to doing pipelines, training, hosting your models and endpoints, and so on. So that's a fairly quick overall whirlwind tour of Vertex AI.